Welcome to this explainer. Okay, let's just dive right in. Today, we're bridging the gap between foundational Python file handling and the absolute superpower that is AI code generation. We're going to see exactly how these two incredible tools combine to make you a ridiculously efficient programmer.
Here is our agenda for today. First, we'll cover why file handling matters. Then, we'll look at file modes and the cursor, followed by the safe with open method. After that, we jump right into AI code generation and wrap things up with some hands-on Python projects.
All right, Section 1, why file handling?
So why do we even need to handle files in programming? Well, have you ever wondered how websites process your CV uploads, or how a banking app just automatically generates a PDF report for you to download? It all comes down to file handling. See, when you're running a Python script, any variable you create only exists temporarily. The moment that program finishes execution, poof, that data is totally gone.
Because of that, file handling is literally the vital bridge between your code's temporary memory and permanent real-world data. It lets you take a user's input, maybe a profile image or a text file, process it, and then spit out a permanent result, like a new CSV or an admission card. Without it, our applications would have absolutely no memory of the past.
Section 2, file modes and the cursor.
Before we actually read or write anything, Python makes us declare our intent using specific modes. W stands for write, but careful here, because it completely overwrites existing data. If you want to keep the old text and just add to it, you use A for append. R, as you might guess, is strictly for reading. And if you attach a plus sign, like W+, or A+, you're basically granting Python permission to read and write at the exact same time.
But there's a bit of a hidden catch here when you start reading and writing. Python uses an invisible cursor to track its place inside a document, exactly like that familiar blinking text cursor you see when you open Notepad. And where that cursor sits is exactly where Python will start its next action.
So, say you open a file and write the phrase, "Hello, Sir Hamza." Your cursor gets stuck at the very end of that text. If you immediately try to run a read command, Python gives you absolutely nothing back because there's no text after the cursor. The fix? You have to use the seek0 command. This teleports your cursor all the way back to index 0, the beginning of the file, allowing you to actually read what you just wrote.
Moving right along to Section 3, the safe method using with open.
The old way of opening files required you to manually type file.close at the end of your script. And if you forgot, that file just stayed open in your system's memory, which is a massive recipe for application crashes or data corruption down the road. The new way, using the with open as file statement, handles this for you. Once Python finishes executing your block of code, it automatically and safely closes the file. It's a real game changer because it completely eliminates the risk of forgetting. Okay, Section 4, AI code generation. This is the really fun part. To show you how much of a shortcut this is, the instructors used a very simple prompt. They asked the AI to create a CSV file with 3 specific columns. Instantly, Gemini generated a perfect script using the CSV Writer module, populated it with placeholder data, and safely saved it. What usually takes 5 minutes of typing and debugging took maybe 2 seconds.
They even pushed it further, asking the AI to build a fun 6-sided dice game. The AI instantly built complete Ludo-style game logic using a random number generator. It was actually so good that the instructors spent more time playing it live on stream than they did coding it.
Now hold on, we do need to pause for a second here, because there is a golden rule to all this. AI is a tool, not a replacement. While it can write code instantly, verifying its logic, checking its security, and making sure it's actually accurate is 100% your responsibility. You simply cannot blindly copy-paste. If you don't understand the underlying logic, you won't be able to fix the code when it inevitably breaks.
And that brings us to Section 5, Python projects. Let's put this into practice.
Let's do a quick mental check. What will happen if our user input is 10, and we run a while loop checking if that input is less than 100, followed by multiplying the user input by 2? Take a second. Can you mentally predict what this block of code will output?
Exactly. It takes your number and relentlessly doubles it loop by loop. 10, 20, 40, 80, 160. The moment it hits 160, it's no longer less than 100, so the condition becomes false and the loop stops right there. It's just a great way to see how a while loop operates against a dynamic threshold.
For our final project, let's simulate a 10-to-1 rocket launch countdown. Instead of a while loop, we use a for loop with Python's range function. By setting the range from 10 to 0 and stepping by -1, we force it into a reverse count. Then we use time.sleep to add a really realistic 1-second pause between numbers. Finally, once the loop finishes, it breaks out and prints liftoff.
We've covered a tremendous amount of ground in this explainer today. The modern programmer doesn't have to memorize every single line of syntax anymore, but you absolutely still need to be the architect. So I'm going to leave you with this to fuel your next project. If AI can instantly generate the perfect syntax for you, what unique logic and incredible applications are you going to build with your own human creativity? Thanks so much for joining me, and keep coding.